Okay, question 4 from December 2012 is called Clara's Child's Savings Account, and it's something that you can use a spreadsheet for. It says Clara has had a child savings account since she was born. Her parents have paid in 250 kroner to the account every month, and underneath is an extract from the first statement from Clara's child savings account. And then it's a summary of how much the parents have paid in every month, 250 every month, and then how much is on the account after that. And it says, how much money have her parents paid in to the account every year? So that's just 250 every month. So 250 times 12 makes 3,000 kroner. The next question asks, how old was Clara by the time her parents had paid in 36,000 kroner? So we know how much they pay in per year. So it's just the 36,000 divided by 3,000, because they pay in 3,000 every year, gives you 12 years. So she's 12 years old. The next question says, when Clara's parents had paid in 36,000 to the child savings account, they weren't allowed to pay in any more because the highest you're allowed to pay in is 36,000. On Clara's 15th birthday, the amount on the account was 42,698 because the bank had added interest onto the account every year. Then it's asking what percentage of the 42,698 was interest that the bank had added. So first of all, the actual interest amount in kroner is 6698 because the parents had only put in 36,000, but there was 42,698 on the account. So the rest is what the bank had added in interest. And the question is asking you what that amount is as a percentage. Now, normally, if I'm working out a percentage increase or decrease on something, I'd be working it out of the original amount. So to figure out how many percent that is, I'd normally be saying the 6698 out of the original 36,000 as a percent. But this question specifically asks you what percentage of the 42,698 was the interest. So I'm going to do my calculation unusually out of the 42,698. So 6698 out of the 42,698 as a percent. So that's 6698 on the top out of 42,698 on the bottom, and then times 100 to make it a percent. So writing that out as a neat answer, well, it comes to 15.69%. And then actually in my neat answer, I've shown where I got the 6698 from. I've shown how it's from 42,698 minus the original 36,000. Question 4.4, it says you can use a spreadsheet file or the supplementary answer sheet in your calculations for the next 2 exercises. It says Clara gets her child savings paid out when she's 21. The interest on her child savings account at the moment is 2% per year. What will the amount on Clara's child savings account be when she reaches 21 if the rate of interest continues at 2% per year? So there is a supplementary answer sheet to this where you can work out each thing, each line by hand and calculate it that way, or you can use a spreadsheet. So I'm going to go into Excel and show you how you can do that on a spreadsheet. So here I am in Excel, and first of all I'm just going to type in the basic information in the same way that it is on the answer sheet. So you've got the word for the rate of interest in cell A1, and then in cell B1 you've got the rate of interest, which is, well, you can type in a 2, but if you type in 2%, then it understands what that means. So when you do calculations with it, you don't have to bother dividing things by 100, because it already knows that 2% means 2 out of 100. And it's just got the words per or. And then in row 3, we've got the headings for the table. Clara's age, which I've not spelt right, have I? There we go. And we've got the amount on the account. And then we've got the interest. Sådan. And then you've got different ages she can be, so 15 years and 16 years. Now, if you highlight those two, you notice a little dot in the bottom right corner of what you've highlighted. And if you just go on that until there's a little black cross and drag it out, it's clever enough to understand what's supposed to go in the next cells and just fill it in for you. So instead of typing all of those ages, I've just done that quick copy and paste trick. Okay, well, I'd like these columns to be different sizes, so I can go to the headings between columns and just drag things out so that they're the size I want them to be. Perhaps I'd like everything to be centered in the cells, so I can click on a cell and then click on a button to put the text in the center. Or in fact, I can click on the top left and select everything, and then just make everything centered. Actually, I'd like where it says per or to be on the left, so I'll just pop that on the left, and then maybe this one on the right to tidy it up. Also, to make it look tidy, you can do things like borders and colors. So if I highlight all of the things that are going to be in a table, then I can click on a button for borders and then say I want borders on everything, and then suddenly there's boxes everywhere. Maybe I want to put that in a different color just to highlight it, and there it is, blue. Maybe I want to make the font a bit bigger. You can click on a button for that. There it goes. So all sorts of things you can do to make it look tidier. So she starts off with 42,698 in the account. Because this is money, maybe I'd like it all to be 2 decimal places. So if I highlight everything in that table, then I can go up to Format, Cells, and then I can either make it number with 2 decimal places or currency if I want, and then I can choose to have a krona symbol after it. I'll just go for number, 2 decimal places, and there's everything to 2 decimal places. I might want to do that with a percentage as well, so up to that one, and Format, Cells, let's say I want to do that to 3 decimal places. That's going to be useful a bit later on. So when she's 15, she has 42,698 in the account, and then they add 2% interest. So the wrong way to do it would be to say that this cell here equals this cell times 2 and divided by 100. Now that gives me the right amount of interest, 853 96, but the best way to do it is link it to the cell that's already got the percentage in it. So I'm going to say this cell here equals, and I want to say 2% of, so 2% times what's in the account at the moment gives me the same 853.96. Now, because that said 2% in that cell, I didn't have to do the dividing by 100 because it already understood that percent means divide by 100. Now, the point with linking it to a formula is that if I change the percentage, say to 3, then it can change the amount in the account because it's always looking at that cell with whatever the current percentage is. So let's change that back to 2 anyway. And then each year, she's getting 2% interest. So when she's 16, the amount on the account will be equal to what she had before, point at that cell, plus the interest that she earned at the end of the year, point to that cell and enter. And then it works out, the two added up, 43,551.96. And then her interest at the end of that year will be 2% of what was on the account. So equals the cell with the 2% in times what was in the account, giving you 87104 as 2% of 43,551.96. So I'm going to do that very quickly. This cell here equals what she had before plus the interest. The interest now equals the 2% times is a star sign, whatever was on the account, enter. Then the next year when she's 18, she gets that plus that. Then the next, at the end of the 18th year, she gets 2% of or times that. When she's 19, she's got what she had before there plus the interest there. At the end of the 19th year, she gets 2% of or times that. So when she's 20, she gets what was on the account before plus the interest. At the end of the year, she gets 2% of or times what was there at the start of the year. And then when she's 21 and she gets it paid out, she's got what she had when she was 20 plus the final year's interest, and that gives 48084.88. So our answer to the question is that she's got 48084.88 when she is 21. And there it is. So question 4.4 amount, see answer sheet. So the answer sheet could either be a spreadsheet that you've handed in. Remember to put your name on things when you print them out. Or it could be the supplementary sheet that you're given in the exam. Question 4.5. What does the interest rate have to be in order for the amount on Clara's child savings account to be 50,000 when she reaches 21? Well, let's go back to the spreadsheet. And here on the spreadsheet, because we set this up as formulas, then we can see what happens when we change the percentage. So if we had 3% instead of 2%, then everything changes, and she's getting 50,983 when she's 64. So the object of this exercise is to play around with a percentage and try and get the amount when she's 21 to hit 50,000. Okay, so 2.5 is too low. Let's try 2.6. Too low. Let's try 2.7. Too high. So let's try 2.65. Too low. Let's try 2.66. Too low. Let's try 2.67. Bit too high. So let's try 2.665. This is why I put the extra decimal places on the interest, by the way. 2.665 is too low. Let's try 2.666. Too low. Let's try 2.667. Bit too high. So it's somewhere between 2.666 and 2.667. On my final answer, I'll just put 2.67% because both of my possible options were rounded to 2.67 to 2 decimal places. So that's near enough. So just putting that in as the final answer. The interest has to be 2.67, and then you'll have done some calculations on a supplementary sheet. This is the one question I've seen in recent years where the easiest way to do it is on the spreadsheet. So I'd be handing in a spreadsheet printout with my name on it, clearly, of course, and the question number. So here are my final answers with question numbers lined up, comments lined up, calculations in brackets and lined up on the left, equal signs lined up, answers lined up at the decimal point and double underlined, and units lined up and heading double underlined. And the marks available are 3, 4, 4, 4, 4.